Start. Please take 5.4 where we left in the morning. We will continue. So 3 plate lap joints in block at least 12 inch from each other. So it should be at least 12 inch from each other and from the tank shell and from joints between annular plates and the bottom. A 3 plate lap is created where the 3 plates come together and all plates are joined to one another by lap threads. Now I told you this is the top angle from where the roof plate will be welded, single side fillet weld. Sometimes it is allowed by the code, instead of using top angle, you can bend the shell plate and you can attach the roof. You can see this is the shell plate. The top shell course, you can bend it and it directly attach the roof. This is also allowed by the code. Then this is bottom lap joint where a shell is heating. So sometimes the thickness is high. There may be thickness variation when the shell is heating. So we have to bend the bottom plate when you are making lap joint so that the top surface will be uniform. And this is another one. These are not part of the exams. Okay, just suppose detail of double fillet welded annular bottom plates with a nominal thickness. Suppose your annular bottom plate thickness is more than half an inch, more than 13 mm. So you have to make a groove in the shell. You can see the shell plate. It is not a fillet weld. It is a groove. They have prepared a groove and then they have made a additional fillet. Now, what is the just started, Mr. Shalu.
Okay.
So this is the groove we have to take it. Then these are not important. Right. Now, okay. So what is the butt weld of the bottom joints? Butt welded bottom joints are permitted by the code. I told you generally bottom joints we are making a lap weld, but if you want to go for butt welds, you can go for it. Okay, this is the one. Just to highlight this one. Butt welds bottom plate shall have their parallel edges prepared by butt welding with either square or V grooves. Butt weld shall be made using appropriate weld joint configuration that it is a complete joint penetration weld. Typical permissible bottom welds without a backing strip or the shown in 5 point. The use of backing strip at least 3 mm thick tack welded to the underside of the plate is permitted. Okay, so you can use it with the backing strip also. Now we will go to the annular plate. See the difference you can see here. Butt welded bottom plates permitted. This butt weld shall be made. Here annular plates, bottom annular plate radial joint shall be butt welded. So if you are making annular plate to annular plate, that joint should be only butt welded. And it shall have complete penetration and complete fusion. The backing strip, if used, shall be compatible to our welding with the annular plate. So it can be either a double V weld or a single V weld with the backing strip. Is both are a single V without backing strip also we can use it. Then shell to bottom fillet welds. When you are using a shell to bottom, see if you take a tank, which joint is more critical to the storage tank is shell to bottom joint. That joint is the highly critical because there will be more stress acting there. Okay, that joint is critical. What should be the fillet weld size of that shell to bottom weld? Shell to bottom, I told it will be a double-sided fillet weld. For high thickness, we will prepare a edge preparation also. For bottom and annular plates with a nominal thickness half an inch and less, the attachment between the bottom edge of the lowest course shell plate and the bottom shall be continuous fillet weld on each side. So when the annular plate thickness is less than half an inch, it is double-sided fillet weld. The size of the each weld shall not be more than half an inch. Very important. This is the maximum size fillet weld allowed. Less than half an inch thickness is half an inch only. That is a maximum size fillet weld. I told fillet weld size means leg length. Okay, and shall not be less than the thickness of the thinner of the two plate joint, that is shell plate or the bottom plate. Suppose half an inch, less than half an inch, maximum thickness allowed is half an inch. Suppose less than half an inch, what should be the size? For example, shell plate thickness and fillet size fillet weld. Shell plate thickness 5 mm means it will be minimum 5 mm fillet weld size. 5 to 20 means 6 mm. 32 means 8 mm, 32 to 45, 10 mm. This is important, open book question. Now, just I will explain it. So, this is your shell, and this is your bottom plate. So, we are welding a fillet weld like this. So, this is your fillet weld. Okay. What should be the maximum size of the fillet weld? I told us the size is leg length. Maximum half an inch. Minimum size depends on the shell plate. So what should be the minimum size? The table is given. Okay. Now that is not important. Now next one, what should be the projection outside? What should be this dimension? Very, very important. How should be the, how much bottom plate should be extend beyond the shell plate? There are two rules. If you take from shell, it should be 2-inch minimum. From the shell, how much it should be? 2 inch. Just I will give you the shortcut. 1 inch is 25 mm. Forget about 25.4. Take it 25. 2 inch means 50 mm. Or from the weld toe, this is a weld toe, this distance should be 0.5 inch. So we have to measure both, whichever is greater, that should be the value. This is very, very important for exam point. So what should be the bottom plate extension? From the shell 2 inch or from the weld toe half an inch, whichever is greater. Whichever is greater, we have to take it. Okay. So that's why I'm drawing every time so that you can better understand what is given in the code. Is it okay? Right. You can see here one requirement is given here. The bottom or annular plate shall be sufficient to provide minimum half an inch from the toe of the fillet weld, reference in 515C to the outside at the bottom plate. So from the toe of the fillet weld, it should be minimum half an inch. Requirement number 1. Okay. Other requirement, what I said, from the shell 2 inch. Where the shell from 2 inch is given, because this is given another allocation. Just to go to here. Okay. Please go to the page number 5-14. We will come back. -14. 5-14. 14. 5-14. 5-14. Okay, highlight that 5.4.2. Bottom plates or annular plates sufficient size shall be ordered so that when trimmed at least 50 mm, 2-inch width will be projected outside of the shell or meet the requirements given on 5157E, whichever is greater. So we have to compare that one, that is 5157. Here 2 inch, highlight this one. Whichever is greater, you should use it. So here 2 inch from the shell. And if you go 5157, so this is the 5157E. So this is a 5157E, whichever is greater. Okay, whichever is greater. Say code generally they will not write straightforward. They will write refer there, refer here, like that one. Okay. Next, roof and top angle joints. So I told curb angle. What is the shell to bottom hub will joined by using a angle. Roof plate shall as a minimum be welded on the top side with a continuous fillet weld all seams. Butt welds also permitted. Roof plates also we can go for a lap weld or you can go for a butt weld. Then what is mean by frangible roof? Say what is mean by frangible roof? What is frangible? It's not adjustable. There is a different meaning. Okay. What is frangible means? Just now I told you which joint is more critical. Shell to bottom weld. Why it is considered as a more critical? Suppose there is how much internal pressure allowed in a tank, I told you in the morning, 2.5 psa allowed. Suppose there is excessive pressure, then what will happen? The shell to bottom weld will fail because that is a weak joint, so it will crack. When shell to bottom cracks, the tank will start leaking. So entire tank will start leaking because that is the bottommost point. To avoid that, sometimes they will make a weak shell to roof joint. The shell to roof joint will be, they make with only a small fillet weld. If there is any pressure, that joint will break and release the pressure. Again, I will repeat, in case of excess pressure buildup, there is a, we will have a vacuum vent, it will operate. Suppose it is not operating. To protect the shell to bottom joint, roof, sometimes roof to shell, they will make only a 5 mm fillet, very small fillet. So it will break and release the pressure. That type of roof is called frangible roof. So frangible roof means in the case of excessive pressure, shell to roof joint will break to protect the shell to bottom joint. That is called a frangible roof. Okay. So highlight this one. For frangible roof, roof plate shall be attached to the top angle of a tank with the continuous fillet weld on top side only. So if you are going for frangible, you should not weld on both sides. Then it will be very strong weld. Only one side only you have to weld. That is highlighted. Then what should be that roof angle size? I told roof angle, why we are using roof angle? So one side it will be attached to the cell, another side roof will be attached. What should be the size of the roof angle? This is open book important. For tank diameter less than 35 feet, we have to use 50 by 50 by into 5. 35 to 60 feet, open book question, 50 by 50 by 6. Tank diameter greater than 60 feet. So this is mm and it is in inches, 75 into 10. Now, what is meant by dead load? What is meant by live load? Very simple. Empty tank weight is called as a dead load. When the tank is filled, that load is called as a live load. Dead load means when it is not filled with any liquid. That weight of that shell, bottom, roof, ladder, attachment, everything. So highlight this one. The weight of the tank or tank component, including any portion allowance unless otherwise noted. Then pressure, how much pressure I told you allowed? 0.125. Tanks made the standard of the standard may be subject to a partial. There should be vacuum also allowed. Suppose vacuum created. Yes, please.
Sir, the weight load illana dead load. Empty are the dead load, sir. Fluid is the pair, sir.
Live load, live load.
Live load. Okay, sir. Thank you.
It is not here, but it is called as a live load.
Sorry.
Okay. Now, I told you pressure, what is the pressure it will withstand? 2.5 psa. Suppose vacuum is created in a tank. When vacuum will be created? When tank will have a vacuum, there may be two reasons. One of the reasons, when you are draining the tank, the vent should not open and allow the air inside. Suppose if it is not allowing air inside, there will be vacuum created. One reason. Another one is called during winter season. If you take in our house, we are using coconut oil. What will happen winter coconut oil? It will become solid. Viscosity will increase. Same way, the oil during winter, the viscosity will increase, the level will come down. Then there will be a vacuum will be created. Vacuum is highly dangerous. That's why we should have a valve immediately to break the vacuum. Air should be allowed inside. So how much vacuum a tank should withstand? So this much, 0.25 kilopascal should withstand. This is an open book question. Tanks that the meter requirement standard may be subject to a partial vacuum 0.25 kilopascal, 1 inch water without the need to provide any additional supporting calculation. That much vacuum they have to withstand. How much pressure they have to withstand shall not exceed 2.5 psi. Pressure they should withstand 2.5 psi. Then what is meant by hydro test in tank? See, pressure vessel, piping, hydro test means a different meaning. We will fill the water and pressurize it like 1.3 times in the case of pressure vessels. Piping it will be 1.5 times. Here there is no pressurizing. In tank, hydro test means fill the tank up to design liquid level, hold for 24 hours. Okay, that is called a pressure test. We have to up to design liquid level, we have to fill the tank with water You have to hold 24 hours. If there is no leakage for 24 hours, the hydro test is complete. Okay. Hydrostatic test.
Static test, right?
Yeah, that is treated. Yeah, static at only. The load due to filling the tank with water to the design level. That is called hydrostatic test. We are not pressurizing. Then these are not important. So please go to the page number 5-30. 5-13. Okay. See, generally, this is the storage tank. So generally, design liquid level, this is the tank height. Why I am mentioning this too? This is the design liquid, this is the top of the shell height. For all design calculation, again very important. All design calculation, H means tank height or design liquid level. Only design liquid level we will take. We will not take the entire tank height. For example, the tank height is 60 feet. Design liquid level only 57 feet. We will use only 57 feet for our calculation. So H means up to design liquid level only. How much you are going to fill it, normal operation. That much only taken as a H height of the tank, not the entire. See, you can see the top shell here. It is here. Now, next one, another also exhaust print exam. When, so you know, welding, shell welding, what are the shell welding we are doing? Vertical weld, that is horizontal. Actually, same welding in pressure vessel, we are calling longitudinal circumferential. That is the terminology used in pressure vessels, but tank, we are using vertical and horizontal weld. When harness test is mandatory. You know, harness test, what is the purpose of the harness? To check how much harness it is there. Harness is related to strength. Okay. When it is agreed between purchaser and manufacturer, we have to do harness test. Point number 1. Harness is required only for group 4 to 6 material. I told group 1, 2, 3 is called low strength, 4 to 6 high strength. Then how much harness you have to take? This was asked in one of the exam. Every vertical, one spot. Every horizontal, every 100 feet to one spot. That is important. Exam point. Vertical joint, if harness, owner asks, owner means purchaser says harness to be taken. Every vertical joint, one spot harness you have to check. Horizontal joint, every 100 feet welding, one spot you have to check. So highlight this one. Any harness criteria should be a matter of agreement between the purchaser and the manufacturer. Should be based on evaluation of the accepted hydrogen sulfide concentration, the possibility of moisture being present, and the strength of the harness characteristics.
Sir, in this case, sir, in this case, it is not the requirement of code. This is the requirement by the
purchaser. Agreement between purchaser and the manufacturer.
So it is not mandatory.
It is not mandatory. It is written in the contract. You have to do it. So it is in the project specification. If it is written, then we have to do it. If it is not written, it is not a code requirement. Okay. If it is written, how to take harness, code explains.
Okay. Sir, each vertical joint and
one spot is there. Next line, I will read it. Okay. See, when specified by the purchaser, I told you again, if owner wants only, it is not a code requirement. Harness test of the welded metal for group 4 to 6 shall be evaluated one of the following methods. So only group 4 to 6 we need. This is the welding procedure qualification for all welding include a harness test of the welded metal and gate zone. So when a purchaser says harness test is required for the tank, during PQR also we have to do harness test. The method of testing acceptance and agree upon purchaser. This is the one what I said. All welds deposited by machine, automatic process shall be harness tested on the product side surface. So which side we have to take harness? Tank inside or outside? Inside is called as a product side. When you are using the automatic process, you have to take inside. Manual welding, any side you can take. That is the meaning of this. That is open book question. The next one is the regularly asked open book question. This is the important. The second line. One test shall be conducted, okay, for each vertical weld, and one test shall be conducted for each 100 feet of circumferential weld. The method of testing and acceptance standard shall be agreed upon the purchaser and the manufacturer. So again, exam question regularly they are asking how many hardness tests we have to take. Vertical, one spot for each joint. You can see one test shall be conducted each vertical weld. Horizontal or circumferential, both are same. Every 100 feet, one test we have to do, one spot we have to take.
Unless
Now,
one test shall be conducted.
Another one. So,
Horizontal, each 30 meter.
yes, please. Any doubts, please?
No, for horizontal, for each 30 meter and vertical.
100 feet, 100 feet. Remember, like this, feet will be easy. Every 100 feet, one weld. We have to calculate the circumference, and every 100 feet, one harness value we have to take. Right now, so you know this. This is bottom roof. Sorry, this is shell roof. What should be the minimum thickness? So, APA 650 requirements for bottom plate, minimum thickness is 6 millimeter. Shell minimum thickness is 5 millimeter. Roof minimum thickness is 5 millimeter. So this is minimum as per any tank. What is the minimum thickness bottom? 6 mm. Shell 6 millimeter. Sorry, 5. Roof also 5. If you go to the 653, I will write 653 requirements also. I use different color. Bottom half of this will be, sorry, we will take 2.5 only. 2.5. Here also 2.5. Here 2.3. This is the 653 requirement. Generally, half of this allowed for a in-service tank. Okay. Just a comparison. So, bottom plate, what is the minimum thickness? For new construction, it should be minimum 6 mm. Shell minimum is 5 mm. Roof also 5 mm. 3 by 16 inch, 5 mm. Okay, right. So, we'll go back.
ஒரே நிமிஷம் சார் காப்பி பண்ணிடுறேன் சார் ஒரே நிமிஷம் சார் சார் ஒரே நிமிஷம் அது
Yes.
அதான் டயக்ராம் ஒரே நிமிஷம் காமிங்க சார் காப்பி பண்ணிட்டுறேன் சார்
Okay, okay. So this is different. Forget about this. This is different. So the green one are 650 requirements. Red one are 650 requirements. Let us first complete 650. Here also we have 653 requirements. When I come 653, we will explain. Everywhere in service tank have lesser values.
Thank you,
Yeah,
sir.
okay. Right. Now thickness. Bottom plates. Highlight this one. All bottom plates shall have a corroded thickness. What is meant by corroded thickness? Hold without corrosion allowance. Not less than 6 mm. Very, very important close book question. Not less than 6 mm. Then what should be the size? Unless otherwise agreed. That means we can go for other size also. All rectangular and stretch plates shall have a width 72 inch. 72 means 6 feet width we should have, but it is not a mandate. Then 5.4.2 already we have highlighted. Okay. Now, what should be the slope of bottom? So generally, as per code 650, the bottom should be sloped to center like this. We have to keep a slope like this. Okay, this is the, see, I am using a digital board, so lines may not be straight. Don't worry. Yeah? Okay, so this. Okay, so what should be the slope? So this is 1:120 upwards toward the center. So slope is 1:120. Now I will ask you the question because it is afternoon session. What is the bottom slope required for (100 feet) diameter tank? We'll check whether we are able to calculate. Slope oda formula enna sollirukam 1:120. What is the tank diameter I have given? For 100 feet tank diameter, how much should slope you have to maintain here? Slope means this is the slope. How much height you have to lift? Calculate it. So slope formula, what is the formula? 1:120. Just to calculate it, even if it is wrong, no problem. I will explain. Hmm?
0.8.
What is 0.8? Inches or feet?
Feet. The diameter is given in feet or
Feet
inch.
only. I give feet only. Understand?
Then feet.
Okay, no problem. How to calculate the slope? See, slope we will not calculate for the diameter first.
Mhm.
We will not calculate for the diameter, but exam question they will give one time because slope is up to center only. Center means radius. So what is the radius here? 50 divided by 120 multiplied by 1. That is the meaning of 1:120. Okay, so if you put it 50 divided by 120, so that is 0.416 feet, or you can want to convert inch, you have to multiply by 12. It will be 5 inches. So feet, it is 0.416. This is the way you have to calculate. Many exam, there will be a question on the bottom slope. Again, whether it is a bottom or roof, slope is always calculated for the radius because center only it will. After center it will be a reverse slope. இது புரியுதா எப்படி ஸ்லோப் radius calculate பண்ணுறோம்? Yes, it is not for diameter, but exam question they will give always diameter because diameter slope mean it is going like this. It is going like this only, it will be a diameter slope. But it is not going like this. It is a returning. So just to write this. Okay, 1:120 slope is important. See, there are many slopes. Each and every roof will have a different slope. That all will be a open book question. Only bottom will be a closed book question. You have to remember the slope 1:120. Open book also they may ask, but even if they ask the closed book, you have to remember.
Sir, in the
English
Sir?
பேசுங்க சார், இது ரெக்கார்ட் பண்ணனும் அதுக்காக.
Sorry, sir. Sir, the dimension 1:120
Yeah.
is for
all tanks.
For all tanks. Is it for mentioned for roof or for the bottom of the tank?
Bottom. We are discussing about the bottom now.
Okay. So even the
different
bottom
roofs will have different slopes. Okay, that is covered in the roof, but it will be a open book question because we have many slopes there. But the bottom is only a one slope, 1:120.
Okay. So even the bottom has a conical shape. The tank.
Yes. No,
okay.
it's not. This will not this much conical because my drawing is very poor. It will be almost look like flat only. A small slope. So 120 is a very small slope.
Yeah.
Yeah, 5 inches will be nothing in a 120 feet diameter tank. Okay. This will be very almost flat only. Look like this only. Okay. Roof will have a more slope. Roof generally they will have 2:12. Okay, 2:12 slope they will have, but the bottom it will not look like a slope. It will look like a flat only bottom.
Actually, what is the purpose of slope?
See, purpose of slope is any water collected, we will come here and we will make a sump here.
Sump, it will accumulate in sump.
At least 3 or 4 location around the tank.
Yeah.
So it will be connected to the pipe outside with the walls, so we can drain periodically to avoid corrosion.
Okay.
That is the purpose of maintaining a slope.
So if the tank is for water storage purpose, then is there any use of storage?
There is no need of slope. See, there is other types of slope also allowed by the code. You can make a slope like this also. Then the sump will be at the center. But 650 covers only this slope. Okay, but this also allowed generally. Slope you can keep Suppose purchaser want only one sump at the center, then it will be slope, it should be reverse slope. But here 1:120 towards the center. Okay. So highlight this one. Unless otherwise specified, everywhere this wording will be there. Unless otherwise agreed between purchaser and, that means code have lot of flexibility. If the purchaser says no, I want to do this way, you can do it. Because tank, they have many types of tanks. So they cannot write a common rule there. That's why everywhere they are mentioning the word.
Yeah, that's why I got doubts at the second. I've inspected only the second model tank. I haven't.
That's why I say, because there are a lot of different type of tanks code. That's why we have a lot of flexibility.
Okay.
But your exam question will be based on 650 requirements. Okay. Unless otherwise specified, tank bottom recurring sloping shall have minimum slope 1:120 upwards toward the center of the tank. That is what code says. But a reverse slope is also allowed, I told. Okay. Then now, what is meant by drip ring? This is again exam question, regularly asking. See, for example, this is our shell. You can see the sketch, no need to draw. This is our bottom plate. This is our concrete foundation. Okay. This side, it is a, what is this side? Bottom or top side of the bottom. This is the underside of the bottom. Technically, this side is called as a product side. Tank inside, we call it as a where we are storing the product. This side is called as a soil side, which is contact with the soil. Okay, soil side, soil with the contact. What type of corrosion will come here? Soil side, that is called soil corrosion. To protect from soil corrosion only, they are giving cathetic protection. Okay. To product side, what side of corrosion will come? Water corrosion, because I told you water will be stored. To protect that, generally they will go for lining. So lining as per 652 here, cathetic protection as per 651 here. Now, suppose we have a concrete pad. Generally, concrete will not corrode like a soil, but still between steel bottom and concrete, water is going inside, rainwater. Then water can corrode. To protect it, we have to put a sheet like this all around the tank. That is called a drip pan. The drip ring is purpose to, it will not allow water between. This is a foundation. You can foundation, there will be no water will go inside. So any water, rainwater will come outside. Now, exam point of important is, what is the purpose of drip ring? To protect from the rainwater, tank bottom, point number 1. What should be the thickness of the drip ring? It should be minimum 6 mm, 3 mm, 3 mm sheet. Then how much it should extend? See, from the concrete, it should be 3 inch away and bend it. Okay. Previous page. Yeah, highlight this one. If specified in the data sheet, a foundation drip ring shall be provided to prevent ingress of water between the tank bottom and the foundation. Unless purchaser specifies otherwise, the ring shall meet the following. Material shall be carbon steel 3 mm minimum thickness. And this is the open to question. The drip ring shall extend at least 3 inch, 75 mm beyond the outer periphery foundation, and then turn down 90 degree up to 90 degree at south. So from the foundation, we have to 3 inch, 75 mm, then we have to bend it. 3 inch from foundation, not from the shell bottom. Foundation is 3 inch, then we have to bend it.
Thickness also something?
Yes.
Thickness
where it is given a minimum 3 mm thickness. Here, you see the cursor here.
Oh, okay.
Minimum material shall be carbon minimum 3 mm. Yes, please now.
Again, it is not mandatory, huh?
It is, see, nothing is mandatory most of the time. Okay. Now, what
instead of this drip ring, can we use rubber type material?
Yes, clay, rubber, everything is allowed. So it is, we have to follow the purchaser. Purchaser means owner instruction. That's all. Okay, so see, you can see clearly say here, if specified in the data sheet, if the owner says we want to drip ring, you have to provide drip ring. That's all. Right. Now we will go to the annular bottom plates. Okay. What should be the minimum width of the bottom annular plate? There is a formula. This formula they will not ask in the exam, but this is important. Minimum there should be 24 inch. This is important. What should be the not less than 2? So minimum width of the annular plate is 24 inch. 2 feet. Annular plate width 2 feet should be there. So it should be 24 inch. Highlight this one. There is a formula to calculate it. 2 TB square root of Fy 2 YGH. This Fy, this is never asked in the exam. Now the next one is, please go to the page number 5-17. Table 5.1 only, annular plate thickness. This is very important. Open the question. What should be the annular plate thickness? So annular plate width, what is the annular plate width?
Minimum
The annular
24
plate
inch.
generally there will be one question. Okay. Width should be minimum 24 inch, 2 feet. Then annular plate radial joint should be butt weld. Either it can be double V weld or you can use a single V with the backing strip. Okay. And another thing, what should be the annular plate thickness? It depends on the shell first course thickness and how much stress will be there. So you can see here, plate thickness of the first shell course and the stress in the first shell course. For example, plate thickness is say 1.25 inch and the stress is say 32,000, then it will be 15/32 inch. So you have to refer the table and answer it. Okay, let's check whether we have question here. Okay, try to answer this question. Annular plate. The nominal thickness of the bottom course is 1 inch. The hydrostatic stress is 23,500. The specified corrosion on the bottom for the annular plate. What is the requirement thickness?
Normal thickness, specific corrosion. Normal thickness 1 minus 15/32.
Which one?
In nominal thickness, should we deduct this 0.125
Plate thickness of first shell course? No. Plate thickness of, this is the nominal thickness. The specified, the nominal thickness means it includes corrosion allowance. No need to add corrosion. This includes corrosion allowance only. So what is the requirement?
23.
1 inch, 23,500. So 1 inch will be here, 23,500 will be, so it will be 9/23,500. 0.236. It will be see 23,500 less than 27,000 you have to take. That's all. See, stress is given 23,500. It is sharing screen.
Yes, sir.
And the thickness they have given nominal thickness 1 inch bottom. Okay. Bottom course thickness 1 inch. So we have to take 1 inch here. So this is the thickness less than or equal to 1 inch. It will come here. Here it is greater than 1 inch. So we will not take this one. And 23,500 means less than 27,000. So we have to match this. Answer is 0.236. Okay, answer is 0.236. So we will have our question bank also on calculation. This is definitely open book. Okay. Right. Answer this question. Try this question. The thickness of the first shell course of our above ground forestings 1 5/8 inch. The hydrostatic stress in the first course is 33,000. What is the minimum permissible thickness of the annular bottom plate? Yeah, screen is sharing, no problem. 1 5/8. If you don't know what is 5/8, just 5 divided by 8, you will get it.
Can you go to the code, sir, once? Table.
1 5/8.
1.625.
So what is 5/8? We have to do 5. What is 5/8?
It's 1.625.
5 divided by 8 is 0.625. 1.625 will be from here. 1.76. Then what is the
3/4.
thickness on the 33,000? I told
3/4.
33,000 will be here. So answer is
3/4.
3/4.
0.75 inch.
So minimum required thickness is 3/4 inch.
Sir, can you share me the screen, sir, please?
Which screen you want? Code or
Question, sir. Question.
question only sharing? I think.
No, sir. It's you're sharing.
Now it's a code.
Okay, it is. Oh, now it is sharing.
Thank you, sir.
So this is the way you have to answer it. Okay. See, open book question. Just you should know which table you have to refer. That is the key. Now we will go to the next call. Is it okay for everybody online, please?
Yeah.
Okay, right. This is the one. Now, what should be the width? Highlight this one, that is not very important. Unless otherwise agreed, shell plate shall have minimum 72 inch. See, bottom plate 72 inch means 12 inch 1 foot. Foot is a singular, feet is a plural. That's all. So bottom plate also 6 feet and shell also minimum 6 feet, but there is a condition unless otherwise agreed by the parties. Now, what is mean by 1 foot formula? Let us work one example so that you will understand. Then we will go. See, exam question, they will not ask everything. So we will now take a tank. Okay. First we have to. So let us. First one. Which material you want to use? Tell me some material. See the chapter on the section bottom. We have so tank material. M Varda. In the table of putting in. Okay, what is the material? A573 M400. Okay, no problem. Whatever you said, I will write. Is it there? Which group it is coming? Group 3 was rolled. Okay. A573 M400. No problem. Okay, no problem. That is a group doesn't matter here. Group doesn't matter here. So tank material is A573 M400. Right. Next one. What tank diameter you want to design? Diameter in feet. Anybody? Online also can answer. There is no restriction.
So what is the question?
See, we are going to calculate the thickness of the shell course. So for this, we need data. So I am asking the question. You tell me the data, then we will calculate together. 20 feet is a small tank. You want a small tank or big tank? Okay, 40. Okay, no problem. Tank diameter 40 feet. Now, number of shell courses. How many number of shell courses do you want? 5. Okay, very good. Say number of shell courses 5. Height of the each shell course. Height of in feet. Yeah, everything we use only feet. Okay, tell me meter multiplied by 3.3. That is 30 meter, not divided by 3.3. Okay, what is your meter? 12 meters. So take it as a divided by 3. Which one? 12 meter multiplied by 3.3.
No, you are asking about the shell course height.
Each shell course height.
It will not come 12 meter and all. It will come only 2 meter, means 6 feet.
6 feet. Okay.
Yeah, maximum one shell width will be 2
6
feet.
feet. 6 feet. 12 meter it will not come. 12 meter na it will be 36 feet varadu. Ore it is the one shell. Yeah. Yeah. Width da height. 2 meter 2.5 only it will come. So it will take it as a 6 feet. So what is the total tank height now? 5 into 6. 30 feet. Okay. Next one, what is the design liquid level?
Yes, round.
I told you design liquid level may be same. You can take 30 feet also, but generally it will be less than the total height. So design liquid level, what will 28? Okay, no problem. 28 feet. So 2 feet less than the total height. There is nothing wrong. We will work it out. So what you want to put? Okay, right. Then what is your liquid specific gravity? Product specific gravity. Product specific gravity. Water specific gravity is 1. So we will take not water. So anything 0.9. Sorry, there is no unit, 0.9 only. Okay. Just I am putting a value. Then what is left out? How much corrosion allowance you want to give? Corrosion allowance. Say I will put some value 0.1 inch. This is the data. Now I will draw this tank. So we have the tank here. This is my row. I have how many shell courses? 5. 1, 2, 3, 4, 5. Okay. Now, first one. So we have shell course numbering. I told it will be from the bottom one. 1, 2, 3, 4, 5. So total tank height is 30, but the design liquid level is only 28 feet. Now, what is mean by 1 foot method? For each shell course, we have to calculate the thickness separately. Suppose for small tanks, understand this, they will calculate the bottom shell course, same thickness we can use for the entire tank. There is no problem. But each shell course can have different thickness also. So different thickness will bottom will be have the high thickness, then it will go. Okay. Now, how to calculate the thickness? For bottom shell course, if you want thickness, there are 2 formulas. There is one thing called TD. TD means a design thickness. TT. TT means test thickness, hydro test thickness. Both thickness we have to calculate. Which one is the higher value? First you have to choose. And there is a table here. We have to compare with the table. And which is the higher we have to choose. Again, I will repeat. There are 3 values you will get for each shell course. Design thickness, by using formula you will calculate. Test thickness, that using formula you will calculate. And based on the tank diameter, there is a table is given. That value also we have to select. So out of these 3 values, which one is the highest value? That is the thickness of the shell course. You understand?
Which one is the third one?
Third one is the table given in the code. Okay. For example, first I will display the see table. Same page it is there. See, you can see here shell page number 5-60. Highlight this one. The required shell thickness shall be greater of the design shell thickness, last line, including any corrosion allowance or the hydrostatic test shell thickness, but shell thickness shall not be less than the following. So this is the table. What is our tank diameter now?
No, the diameter is
40 feet. We have taken 40 feet. What should be the 40 feet minimum thickness? So that is the 50. So less than 40, it should be 3/60. This is the feet. Less than 50 feet tank diameter. What should be the thickness? 3. So you can see here. Our tank diameter is 40 feet. 40 na less than 50 la da varum. 15 enga varudhu? 5 mm is inches na 3/16 inches. So table value for our tank is 3/16 inches.
Table number, sir. Table number
Table number is here. There is no numbering here. This you can see the page number 5-17.
5-17. Yes.
I'm displaying, right? Yes.
Okay.
I'm displaying here. So our tank diameter we have taken 40 feet. So it is come as a less than 50 feet. So it will be 3/16 inch. Okay, that is a table value. So table value I will write here. Table value is equal to 3/16 inch. Now I told you have to calculate TD and you have to calculate TT. So where is the formula? What is meant by 1 foot formula? Every shell course from 1 foot we will calculate the thickness. For example, bottom joint from 1 foot we will calculate thickness. That thickness will be considered the entire shell course thickness. Forget about why this design formula come. That is a formula. Now the important thing is how to take the H. This is the where people are studying. H means from the bottom of a particular shell to the design liquid level. For example, what is the design liquid level for from here to here? 28. So for shell course 1, H will be 28 feet. Because we are taking design liquid level. For shell course 2, what will be the H?
28 minus
28 minus each shell course how much? 6. So 28 minus 6 on the 22. Shell course 3. 22 minus 60. 16. Shell course 4. Because we have to take from here. 16 minus 6. 10. Shell course 5. 10 minus 6. 4. Where people will struggle only to check. If you take H wrong, the answer will be wrong. H na purida and the bottom level evlo height irukudho design liquid level varaikum. So you have to minus the shell course over shell course. Bottom shell course it will be the entire design liquid level. So what is the design liquid level? 28 feet. Now this is the formula. I will write the formula. You will do the calculation. So we will go to the 1 foot formula. We will come back. So please go to the page number 5-23. 5-23, 1 foot formula. So this is the US units. There is a formula in SI unit we will not use. TD is equal to 2.6D H minus 1G divided by SD plus CA. TT is equal to 2.6D H minus 1 divided by SD. Now you know 2.6. What is the tank diameter? 40 feet. H design liquid level. Now I told you how to take the H. What is the G? Specific gravity we have taken as a 0.9. CA correction allowance we have taken as a 0.1. Now left out is SD how to take and SD how to take, right? Any doubts here? Now SD you have to refer this table. You can see here SD table. So page number 5-21. So which material we have choose? 573 M400. Check 573 M400. 573 M400. That is 573 M400. That correct தானா அது? இது? அதான் நீங்க SI டேபிள்ல பாத்திருக்கீங்க. நான் அப்பவே டவுட்டா கேட்டேன் உங்கள்ட்ட. M ங்க டவுட் வரணும்னு கேட்டேன் நான். You have taken SI unit. That's why I asked you doubt. How M is coming? You told. Okay, no problem. You have taken the SI unit, so change the material to the same material will be there in 573 grade 7. Another doubt like
573
grade 70 because this is the SI unit table they referred. A 573 grade 70. So 573 grade 70. Now, so why 73 grade 70? Okay, no problem, no issue. So 573 grade 70. What is the SD value? It is given as a 28,000. ST value it is given as a 30,000. 28,000 and 30,000. Is it right? Now calculate both. I will display the question here. So you have the code. Calculate what is ST, TD, and what is T.
SD, how
Use
much?
the- I think whiteboard is displaying to you, everybody. Yeah. Calculate the TD. Which shell course? We will calculate first shell course. Calculate for the first. First shell course, what is the formula? TD formula? 2.6. What is the H? 28 minus 1. 28 minus 1. 27. For first shell course, H is 28. The entire design like below. So H minus 1 or 28 minus 1. So TD is equal to 2.6 H minus 1, 28 minus 1, 27 into next another H minus 1. D ja. D diameter is okay. Okay, no problem. Both will same. Okay. Formula is 2.6. Okay, 2.6 into dia is into 28 minus 1, 27 into G 0.9 divided by what is the SD? 28,000 plus correction allowance 0.1. Then next TT. What is the formula? Okay. That is same 27. What is the ST? 30,000. Okay, calculate it.
So D is equal to 40. H is equal to 28.
28, yeah. H is equal first shell course. We are calculating first is 28. They have to design liquid level.
Okay, then G is equal to?
G I given here specific gravity. You can say G specific gravity.
Okay, specific gravity.
Yeah, G is specific gravity. This is CA correction allowance. It is the H.
SD.
First shell course.
SD 28,000, right, sir?
ST 28,000 only, I think.
Yeah.
The ST. What is the first formula? SD. SD, what is the SD value? 28,000. ST 30,000. Okay. They are right only. So 2.6 into 40 multiplied by 27 multiplied by 0.9 divided by 28,000 plus 0.1. So 0.190. This is the first one. Second shell, this one, TT 2.6 into test thickness 40 multiplied by 27 divided by 30,000. 0.0936. So what is our value? 3 by 16. This is 0.1875. So which value we have to take it now? TD we have to see. We have 3 values. I will round it. This is what you are calculating, the first one. Second one 0.00936. Table value 3 by 16. 0.1875. Though this is the tank shell course. TT இருக்கு பாருங்க. ST எடுக்கணும் இந்த பாருங்க. TT எங்க இருந்து எடுத்தீங்கன்னு கேட்டிங்களா? Another one இங்க இந்த பாருங்க. இந்த டேபிள். Page number 5-70. It is 3 by 16 inch. Now, how many of you don't understand? Please ask again. I will repeat.
No,
okay, they will give you some data, but please remember, exam they will not ask you to calculate everything. They will ask you to either calculate TD or TT. But you have to understand H will differ. H means it is the from the bottom that shell core, second shell core na, second shell core is bottom joint to the design liquid level. Third shell core means third shell core is bottom joint to the design liquid level. Yes, please.
2.6.
This formula is 653. Also, we have a formula, same formula. This is called 1 foot formula. Yes. Now, what is your doubt? See, we have to calculate TD. We have to calculate TD means design thickness. TT means test thickness. Then we have to take the table value. Out of the three, whichever is the higher value, you have to take. So our value here 3 by 16 na 0.1875. Whereas TD we got it 0.19. So 19 is higher than this value. We are taken as a 0.19. Suppose it is coming 0.1, then we will take 0.19. 16 will be the 0.1875. 3 divided by 1875. Yes. Now, exam again I will repeat. 650 generally 1 foot formula they will not ask in the exam. 653 see 1 foot formula question is there. So exam question generally oriented based on the in-service thing. Yeah, you can take. Yes, please. Yes.
We have two readings. No, TT and TD. Which one we should select?
So we have to select the higher one. Which one is higher? 1875 is higher, right? Sorry, 1.19 is higher, right?
Okay.
What is the value you got? TD and TT.
Mine is wrong. That's okay. I will calculate later.
Okay. See, we have one TD. See, I will write here next page because there is no space. Sorry, you want to take photo? Take.
Yeah.
2 minutes.
Yeah.
Let me take a screenshot.
Yeah.
Sir, excuse me, sir. I'm copying the question, sir. Just give me a second, sir. Please, sir.
Sir, take screenshot and then copy later.
Okay, sir.
So whichever is the higher value, we should consider that one.
Yes, I will write it here. Sriram, it is okay?
Hi, sir. I'm done, sir.
Okay.
Thank you.
So I will write this is, you have to understand shell thickness is greater of TD or TT or table. So what is the table where it is given? Page 5.7. What is the page number? 5.17. Page 5.17 value. So which one is the higher value?
Or table. Okay, understand.
There is no table number. It is given in page number only.
As per our table, it was 3 by 16.
3 by 16 will be 1.1875.
3 by
just 16. To put 3 divided by 16.
Yeah, 0.1875.
But we have 0.190 here. Okay, our calculated.
So as per
0.190 TD. So that is the higher. We are taking 0.190. Okay, this is the because it is 0.1875. It is 0.190. So we have three values: 0.0936, 0.1875, and 0.190. The highest value is the 0.190. So we have to take 0.190.
What? Okay.
Okay. Now, exam question, they will not ask all these things to calculate. Either they will ask TD or they will ask TT. Okay. But you have to understand how the code is written.
Can I ask you one question, sir?
Just a minute. Yeah. Okay. Yes. Yeah, TD. Separate question will be there. They will not ask to combine everything.
They are only asking, give the data.
Data, they will ask you this. We will work out one question also. Okay. Yes, Sriram. Yes, please.
Sir, earlier you mentioned me that we're gonna take 1 inch from the bottom, right? Is that right, sir?
1 foot from the bottom. That is called 1 foot formula. I will explain the formula now.
So 1 foot from the bottom. So my question is, so if you're going to take the second point in the shell 2, are we taking the 1 foot from the joint of the weld, or how are you actually taking the second point for the second one?
See, each shell core thickness is calculated from the bottom joint 1 foot above. That's why this formula is called 1 foot method. Okay. Okay. That's why the formula have h minus 1. The formula we have h minus 1. Remember, the minus 1 is because it is taken 1 foot from the bottom.
Okay, sir.
See, what is the first shell course h? Actually, we written
28.
28. But how much we are using in the formula? 27. That's why 1 foot formula.
No.
1 foot.
This is for the shell 1. What if it's going to be using the shell 2?
Shell 2, it will be what is the h here? Shell 2.
It is 22
minus 1.
22
Yeah.
minus 1. No. My question is not about the formula. My question is, so if you're going to take the second point, how are we going to take it from the bottom?
No, we are not going to take it from bottom. You are talking about the second shell course?
22. Yes.
Yeah, 22 course, the second course bottom joint only here. You can see I am drawing here.
Yeah.
From only this is the one. If you want to check the third shell course, you have to take from here. Fourth shell course, each shell course bottom joint only we will take.
So
it is not from here.
So from the east shell course bottom, you're going to take 1 foot above.
Yeah, 1 foot above. Right, exactly.
Okay.
Now, how the exam question will be asked if they ask? So answer this question. So this is your question bank. Let me check. Okay. So calculate the 1 foot method, the design shell thickness TD in inches of the following description: 650 shell material ASTM A516 grade 60, design liquid level 50 feet, nominal tank diameter 180 feet, design specific gravity correction. Calculate this and then calculate this also. Same, using the same data. Then calculate the minimum required things. Okay, answer this 3 questions. 47, 48, 49. This is the explanation so far. So you have to calculate the 1 foot of the hydrostatic TT in inches of the above referred tank when water is used for the test. The water means what is the specific gravity?
1.
Okay, 1. That's why there is no. See, if you take this formula.
570.
See, I will 1 minute. I will complete this one. Then we'll highlight it. Then we'll go to this. Okay. Just to go to the allowable. Okay. You'll work it out. No problem. You'll work it out. Okay, work it out. Okay, work it out. So you understand the formula now. No problem. Okay. Answer the question 47, 48, and 49. So you have to calculate 47 TD and 48. 47 TD and 48 TT. Just 47, 48 attend. 49 leave it. So you have to refer always B table, not A table. Huh?
Okay. Diameter. Yes.
Everything is mentioned. There's no problem. Question number
below 122, 200 thickness.
Just to calculate. Just to calculate the 47. Calculate 48. 47. What is the answer?
5/16. 0.3125.
Huh? So this one will get 1.068. 47. Then calculate the 48 also. Same tank TT. Which one? First one? Where you did the mistake. So the answer should be correct. I think I worked out already. Huh? No. First one I am taking, second one you are taking. See, what is the stress value you are taken? Yeah, SD. What is the SD value? 21,300. So 2.6 into the formula. D, what is the D? What it is into, that is 49, multiply by 0.9. Okay, divided by, okay, plus 0.1. Okay, what answer you are getting? Calculate it. That's it is some calculation mistake. I will calculate it. 20.2.6 into, no problem. 1.180 multiply by 49 multiply by 0.9. So it is 20,008.8 divided by 21,300. So you will get 0.968 plus 0.1. So 1.068. So so it will be 0.968 plus that is 1.068. Answer is correct. A is correct. If you go to the TD, next one, TT, just 2.68, 180 into 49 divided by 24,000. So answer is 0.955. That also correct. 49 no need, leave it. எதுக்குங்க 48 ஆன்சர் வந்து 0.95. So if you are getting 47 option A 1.068, your 0.955, then it is answer is correct. So this is a way. Yeah, exam question will be like this. Either they will ask you, if they ask you only TT or TD separately, they will not ask you to compare everything into this one. Okay. Now, so let us go to the code book so you can work it out. Okay. So please go to the page number 5-16, last shell design. Shell design. Just I will complete this one. Tomorrow we will carry tomorrow. Okay. The required shell thickness shall be. This is what I said. Highlight this one. Greater of 5-16 last line. The required shell thickness shall be greater of design shell thickness. Yes, please.
Sir, we are. It's not sharing the online screen, sir.
Yeah, sharing now. Yeah, it is sharing now. Is it okay?
Yes, sir. Yes, sir.
Okay. The required shell thickness, page number 5-16, last line. The required shell thickness shall be greater of the design shell thickness, including any corrosion allowance or the hydrostatic shell thickness, but the shell thickness shall not be less than the following. So this is the table. For example, 180 feet diameter means it should be minimum 8 mm. Less than 50 feet diameter, minimum 5 mm shell thickness. 50 to 120, minimum 6 mm. I am selling in mm. The greater than 200 feet, minimum 10 mm. Now, this annular pit already we have seen. Then please go to the allowable stress. How we are taking the stress? You know the allowable stress 28,000. There is a formula for allowable stress. Highlight this one, open book. It was asked in one exam question also. How we are calculating allowable stress? Highlight this one. The maximum allowable SD. SD will be the SD used to calculate the SD. The last line is important. SD shall be the 2/3 of yield strength or 2/5 of the tensile strength, whichever is less. Yield strength, tensile strength, they will give in the exam. No need to check. So if they give yield strength and the tensile strength, you have to calculate SD is 2/3 of the yield strength and 2/5 of the tensile strength. How the SD is calculated? Highlight this one. The hydrostatic stress is 3/4 of the yield strength and 3/7 of the tensile strength, whichever is less. If they ask, all will be open book only. Okay, generally we can directly refer the table, but sometimes if they give tensile strength and yield strength, you should know how to calculate. Okay, then this table, so you already know this one. Highlight the 5623, page number 5-20. Annexure A, we have annexure A also. Permit this formula only, 1 foot formula only. Highlight this one. Annexure A permits an alternative shell design with a fixed allowable stress, 21,000 pounds force and a joint efficiency 0.85 or 7. The design may only use the tank shell thickness less than or equal to half an inch. Just to highlight, mark it as a open book, we will see in annexure A. Annexure A, there is the alternative formula also there. Highlight this open book. Now this is the 1 foot method. So what is meant by 1 foot method? The 1 foot method calculates the thickness record at design points 1 foot above the bottom of each shell course. Next line is important. Annex A permits only. The method shall not be used for tanks larger than 200 feet diameter. These formulas are allowed only up to 200 feet diameter. Above 200 feet diameter, we have another formula which is not part of our exam, variable point design method. Okay, this is the SD formula and the SD. So this is how to calculate the stress. Okay, this is a formula here, page number 5-23 formulas here. You can see TD design shell, hydrostatic shell, nominal, design liquid level. What is the definition for H? Page number 5-23. Is the height from the bottom of the shell course under consideration to the top of the shell, including the top angle, if any. Okay, this is the one. Okay, this is the variable point. This is not part of our exam. Okay. On the recording stop பண்ணமா